Hey guys, morning everyone. Sorry for all my weird introductions in the last few videos. I'm just bored in the house and I'm in the house bored, so I guess that's what happens. So in this video, we're going to be doing 10.6, which is secants, tangents, and angle measures part 2. There's only one theorem for this video, and this is the one theorem. It does have 3 different examples, so it kind of looks a little complex, but it's really just the same theorem, just with different examples of it. So this theorem says, imagine that you have either 2 secants or 2 tangents, or you can have 1 secant and 1 tangent, and imagine that those lines intersect in the outside of the circle. Look at the 3 different pictures here. Where's the point of intersection? In the first one, the point of intersection is right here, where the A is. That's where the 2 lines are intersecting with each other. In the second one, it's the same thing. That's the point of intersection. And in all of them, it's the same. The point of intersection is right at the angle. So all of them are forming an angle. It's angle DAE, like this. This is the angle that's formed, and it's formed right at the point of intersection. And something cool is happening with the angle. The measure of angle A is always going to be half of the difference. So it's not an average anymore because we're not adding them, we're subtracting them. Half of the difference of arc DE and arc BC. And it's the same thing, arc DC and arc BC, or arc BDC and arc BC. It's always going to be the arc that's more on the outside, and then the arc that's closer to where the actual angle part of it is. So it's always going to be like this arc minus this arc, or this arc minus this arc. So the measure of the angle is half of the difference of the 2 arcs. So that is the only theorem that we're going to do today. Let's go ahead and use that theorem in some different example problems. In the first one, we know that the measure of angle L is going to be half of the difference of the 2 arcs, but we don't know what both of the arcs are. We only know what the 102 is. How do we find the red one? You can just subtract it from 360, right? You do 360 degrees minus the 102. That's going to give you the red arc, which is going to be, let's see, 260, 258. So the red one is going to be 258. So the measure of angle L is going to be half of 258 minus 102. So 258 minus 102, that's going to give me 156. And then when I do 156 divided by 2, that is 78 degrees. So the first one, the measure of angle L is 78 degrees. All right, now for the next one, the measure of arc CD is what we're trying to find. I'm going to set this problem up by saying the measure of angle A, 56 degrees, is half of the difference of the 2 arcs. One of the arcs is 95, and the other arc, well, that's what we're trying to find right here. And we can't just do 360 minus 95. Why can't we do that for this problem? It's because look at this over here. We've got this little part of the circle that's not included. So we do have to set the problem up like this, and we have to solve it for x. So we're going to start solving it for x by multiplying 2 on both sides. So we're going to get 112 is equal to x minus 95, and then we're going to add 95 to both sides, and we get 207 degrees. So the measure of arc CD is 207 degrees. I'm just now realizing I just went and used an x. This is what I meant. So x is the arc CD. You may have caught on to that already. So x was just this length right here. Or the measure, I guess I should say, the measure of arc CD. All right, here's 2 problems for you guys to try. Go ahead and pause the video, give these 2 problems a try, and then you can watch the video for the answer. All right, this first one, 71 degrees is, I think that's this part here, RT. Yes, because we're trying to find the measure of angle S. So the measure of angle S is going to be half of the difference of 179 and 71. So we just have to put this into our calculator. And we get 54. So the measure of angle S is 54 degrees. That's for the first one. All right, now the second one here, they tell us the angle is 68. So 68 is going to equal half of the difference of the two arcs, 224 and the other arc, which we don't know. I'm going to use an A. You can use any variable. And when I use an A, the A is referring to this arc measure right here. Now I'm going to multiply both sides by 2. 136 is equal to 224 minus A. And we have to add A on both sides and then subtract 136 on both sides. So 224 minus 136 is 88. So the measure of XZ is going to be 88 degrees. Here's another problem for us to do together. This one's about science. The diagram shows the path of a light ray as it hits a drop of water. The ray is bent or refracted at points A, B, and C. If the measure of arc AC is 128 degrees and the measure of arc XBY is 84 degrees, what is the measure of angle D? The measure of angle D is half of the difference of the two arcs, 128 and 84. So we're just going to put this into our calculator and we get 22. The measure of angle D is 22 degrees. All right, here's one for you guys to try. Go ahead, pause the video, try to solve this problem, then you can check your answer. All right, in this problem here, 25 is the angle measure, so 25 is half of the difference of the two arcs. So now we have to solve it for x. Multiply both sides by 2, so 50 is 110 minus x. Then we have to add x to both sides and then subtract 50 on both sides. So we get that x is equal to 60 degrees. All right, I have one last thing to show you. Don't freak out when you see it. It's going to be overwhelming at first, but it's not going to be that bad once you kind of look at it for longer than just 2 seconds. So here it is. This is a chart that is supposed to be helpful in organizing some of the theorems that we have been learning about in this section here about secants and tangents, because we've learned a couple different theorems. So if you study this chart here, it will tell you how to find some of these different measures. For example, the first part of the chart is saying if you have intersections that happen on the circle, like the vertex of this angle is on the circle, then this is the formula that you would use in order to find a missing piece of information. If the intersection happens inside the circle, like in this example right here, the second example, then this is the formula that you use. And if an intersection happens outside the circle, then this is the formula that you would use. That's what we did today. So if you would like to, this is in your textbook in section 10.6, this chart right here. It might be useful, just wanted to show it to you guys as a way to kind of keep track of some of the different things that we have been learning about. So that's it for this video. Thanks for watching. Remember to submit your notes on Canvas and have a great rest of your day.